Hello everyone, good day. Let me introduce myself first. By the way, my name is Jasamedi Tagbo, Best A2 from Group 3. So I hope you're all doing great today. And for today's video, we're gonna be discussing the steps in scientific method, the fundamental tenets of scientific method, and lastly, give the clear comparison between scientific theory and the scientific law. So without further ado, let's get right into the video. So before that, let me ask you a question. So what comes to your mind when you hear the word scientific method? So scientific method is defined as the method of research in which a problem is identified, relevant data are gathered, a hypothesis is formulated from this data, and the hypothesis is empirically tested. The scientific method is the process of objectively establishing facts through testing and experimentation. The basic process involves making an observation, forming a hypothesis, making a prediction, conducting an experiment, and finally analyzing the results. Why thus scientific method is important? The scientific method is important because it's a standardized approach. The steps used in scientific method are systematic. So scientists conduct experiments in a standardized manner. This means that their experiments can become more widespread. And we have here the 6 scientific methods. This include observation, research, hypothesis, experiment, analyze, and lastly, the results. First, we have here observation. Scientific observation can occur in a lab setting or a natural world. For example, watching an apple fall from a tree could be an observation. Noticing that fish only come to a particular part of the river in the early morning is also an observation. Smelling garbage decomposing is another example of observation. Research. Research conducted for the purpose of contributing towards science by the systematic collection, interpretation, and evaluation of data. Some people use the term research loosely. For example, people will say they are researching different online websites to find the best place to buy a new appliances or locate a lawn care service. Hypothesis. A hypothesis is an idea or proposition that can be tested by observations or experiments about the natural world. In order to be considered scientific, hypotheses are subject to scientific evaluation and must be falsifiable, which means they are worded in such a way they can be proven to be incorrect. For example, if we increase the amount of light during studying, then the participants' performance in the test scores will decrease. Experiment. So put your hypothesis on the test. For example, let's say that you and your lab team are interested in the question: what percentage of nitrogen in the soil will cause the tomatoes to be grow to the tallest? A reasonable hypothesis might be, if potato plants in my garden are given additional nitrogen in the soil, then they will be grow taller than the plants that receive no nitrogen. Analyzed. Analysis refers to inspecting and breaking down collected information that could be qualitative or quantitative to understand the natural world better. One example of this, Charles Keeling in 1958 started to record the carbon dioxide emissions each day from his laboratory in a month. His data was analyzed by many different scientists pointing towards climate change. Keeling's data has transformed and ignited climate science as we know. And lastly, the results. The results section provides a space to present your key findings in a purely objective manner and lay the foundation of the discussion section, where those data are subjectively interpreted. Before diving into this section, identify which graphs, tables, and data are absolutely necessary to telling your story. Then craft a descriptive sentence or two that summarizes its result, referring to corresponding table and figure numbers. Rather than presenting the details all at once, write a short summary about each data set.
Hi, good day everyone. I'm Ira Lianas and I will be discussing the fundamental tenets of scientific method. So first, what is scientific method? Scientific method is the process of objectively establishing facts through testing and experimentation. The basic process involves making an observation, forming a hypothesis, making a prediction, conducting an experiment, and finally analyzing the results. The scientific method uses a series of steps to establish facts or create knowledge. The overall process is well established, but the specifics of each step may change depending on what is being examined and who is performing it. The scientific method can only answer questions that can be proven or disproven through testing. The scientific method has 5 basic steps. The first one is make an observation or ask a question. The first step is to observe something that you would like to learn about or ask a question that you would like to answer. This can be specific or general. The second is gather background information. This involves doing research into what is already known about the topic. This can also involve finding if anyone has already asked the same question. The third one is create a hypothesis. A hypothesis is an explanation for the observation or questions. If proven later, it can become a fact. And the fourth one is create a prediction based on the hypothesis. The test should establish a noticeable change that can be measured or observed using empirical analysis. It is also important to control for other variables during the test. And the last one is analyze the results and draw a conclusion. Use the metrics established before the test. See if the results match the prediction. So now, let's hear all the examples of fundamental tenets of the scientific method.
I am Chris Abuso, and in this video, I am assigned to make examples of 10 scientific methods. So the explanation is, scientific method is the process of objectively establishing facts through testing and experimentations. And in scientific methods, there are 5 steps to gather information or to establish facts and to create knowledge. So we have the first step, and that is make an observation or ask questions. Example, I observed that within this month, our farm crop production dropped its percentage. And the second is gather background information. Gather background information is something that finding someone that has already asked the same questions or the same problem with yours. And the third is create a hypothesis. Create a hypothesis. It is the steps that explaining the answer of the first step or the observation. Some examples would be the technician of farm did not apply fertilizer. And the fourth step is create a prediction based on the hypothesis. These steps from the word itself, you will analyze and create testable prediction based on the hypothesis. Some examples would be if we trade a new technician in our farm so that our farm crop production will increase its percentage. And the last steps, we have the analyze the result and draw a conclusion. In this case, you may tally the percentage or establish before the test, see if the results meet to your prediction. For example, after we let the new technician operate our farm, our crop production increased to our estimated percentage.
Before that, let's define what is hypothesis. Have you ever heard the word hypothesis? Well, for me, yes. When we say hypothesis, which many characterize it as an educated guess based on observation and prior information. If you talk to your friends about a well-established scientific theory, she might respond, "Well, it's just a theory." But a discussion on scientific law rarely comes to that conclusion. Why is that? If enough evidence gathered to support the hypothesis that it can be considered as a theory. Based on Bradford theory, it is a scientific method becomes acknowledged as a valid reasoning or explanation of a phenomenon. Or scientific theory considered as the skeleton for observation and facts. If the theories had enough support, often it will refer to as law. Scientific law based on unalterable fact, proof, evidence, and result state that something will happen under a certain condition can be represented by a mathematical statement or do not change. Example, law of Newton's and law of inertia. Scientific theories based on observation, proven, and but still testable. Evidence attempt to explain why something happened. No mathematical statement and even evidence can change. Some of these examples are the theory of relativity and the Big Bang theory. The function of scientific laws and theory differ. It may be possible to anticipate the potential hair colors of your unborn child or the distance a baseball travels when fired at a specific angle using a scientific laws. A theory, on the other hand, seeks to offer the most logical justification for why things happen the way they do. A theory may be used gravity to explain the parabolic flight of a baseball or dominant, and recessive genes explain how brown-haired parents produce a red-headed child. In simplest terms, a law predicts what happened while the theory proposes why. Always remember, in scientific law, you will see that each of the following rules only seek to describe a phenomenon. They do not attempt to explain why phenomenon occurs. Theory, not law, is responsible for articulating why. Theory, not law, is responsible for articulating why. In theories, always remember offer an explanation for observation, phenomenon, while some are unquestionable. Others are in debate. However, they are not merely contemplation or ideas regarding to a potential reason for happening. Instead, they have undergone intensive specific analysis. Scientific laws focuses solely in describing what and prove. Scientific theory explain why or explore why, prove but still testable. That's all for today's video, and we are the group 3. Thank you for watching.